All right, so PavementDesigner.org really made for local streets and local roads, and that's why it perfectly fits in with this session. Now, PavementDesigner.org, not just for streets and local roads, it also does parking lots, industrial, and intermodal facilities as well. It's a great resource for really designing any type of concrete or cement-based pavement. You can see down here the list of things that it can do beyond just jointed plain concrete pavement, which is our conventional concrete pavement. We do concrete overlays, composite pavements, roller compacted concrete, which Brian just alluded to a little bit ago, as well as looking at some of those cement-treated bases and soils or full-depth reclamation, which Roger just talked about as well. So there's a lot of things that we can do with PavementDesigner.org. Now, PavementDesigner.org was really brought together by the entire concrete pavement industry. So while Andy and I worked really hard from the ACPA side, Brian helped out a lot from NRMCA as well. We also had people from PCA and the RCC Pavement Council help out a little bit as well. Even Jim Mack, who talked in the this morning's session as well, he was very instrumental in getting this thing done as well. So it was really a big group effort to make this thing actually occur and make it the tool that it is today, which you guys will see in just a few minutes. You can see how powerful PavementDesigner.org is and how easy it is to use. And that was really a testament to the teamwork from all of the concrete pavement industry. So, PavementDesigner.org, here's your first little look at what the website actually looks like, but I also like to show the little map down here in the bottom right, where that's kind of your framework for what all it can do and how you get to all of those different designs. It looks and feels a lot different when we get onto the website, where you're actually looking and seeing little pictures of what you're actually designing for. So there's a lot of good information on there. But we're going to focus mainly on the streets and local road side, doing conventional concrete pavement design. All right, so I always like to talk about why this tool is actually needed and why we took the time to develop it and put all this money into creating a tool that's out there and free for everyone to use. And it comes back to this slide that I showed yesterday. And so the main design methodology for a very long time was AASHTO 93. And AASHTO 93 is a pretty good design, but it's fairly old. It has its roots back in the 1950s with the AASHTO road test, which was a 2-year road test. And based on that, they developed the 1962 guide, or 1972, 1986, and 1993 AASHTO design guides. But they were really all based on that AASHTO road test. And that AASHTO road test has some major drawbacks, especially for concrete pavements. And so we really more recommend these current design tools that have been developed recently with AASHTOWare's PavementME and the PavementDesigner.org resource. And so you may ask, why are there 2 different design tools? Which one am I supposed to use? Well, here it's important to understand that AASHTOWare's PavementME design tool is really meant more for DOTs and more kind of interstate and highway level type pavement. It's a fairly complex tool. Additionally, a license for 1 year is over $5,000, so it's a very expensive tool. And so that's where the concrete pavement industry recognized that there needed to be a free tool for designing concrete cement-based pavements, and that's why Pavement Designer exists. To have a mechanistic empirical tool that's more accurate for designing concrete pavements than our older empirical AASHTO 93 design methodology, that's still available for free and doesn't have that cost associated with it that PavementME does. Now, PavementME is a great tool. It's just fairly expensive, and it's also fairly complex for someone who doesn't do a whole lot of pavement design. So to kind of illustrate that movement from that empirical AASHTO 93 design methodology, here's a summary of state agency practice back in 2005. About 15 years ago, most states were using one of those AASHTO design methodologies, the 93 guide or the 86 or 72 guides. Doesn't really matter. All of them are based on the AASHTO road test. You had one early adopter of the PavementME, which was MEPDG at the time, and that was Missouri. That's because they were kind of the pilot state for getting PavementME implemented. Now, if we move forward to 2016, just a few years ago, you can see most states in this map are either green or blue, and those are indicating that they are either implementing PavementME or they are working towards implementing PavementME. So they already have or they're working towards it. You have a few states that are doing their own thing. Illinois and Texas actually have their own state-developed method for designing concrete pavements, but most other states are moving towards that mechanistic empirical design for concrete pavements. Now it's important to remember that these tools, these AASHTO developed tools, are really meant for state and federal agencies. So you can see here that isn't a very big significant portion of the actual lane miles that we have out there that still need pavement design methodologies. So you can see for towns, cities, and counties, we have a big portion of our pavement network out there that still needs to be able to design pavements, and they're kind of getting left behind. That's why we have PavementDesigner.org. That's why we developed it. So if we look here, here's our big old map of all the different things that Pavement Designer can do, and you can see here we're going to focus on jointed plain concrete pavement. And I show this because it's important to know that while PavementDesigner.org is a new resource, brand new, we released it in 2018, it's based on existing design methodologies that have been improved and adopted over time. So you can see here what we're doing here is based on the PCA method, which originated early in the 1960s, but has evolved and improved and incorporated different things all the way to its inclusion in PavementDesigner.org. So let's talk a little bit about PavementDesigner.org, how it's actually calculating calculating the thickness for concrete pavements. It's just going to be a brief little overview, a few equations. We're not really going to go through them too much, but it's important to understand what it's actually doing. So Pavement Designer, for designing concrete roads, is actually looking to design against cracking and faulting, which is how concrete pavements actually fail. It's very similar to what PavementME does. It's looking at the cracking and faulting of a concrete pavement. Except Pavement Designer is more tailored for streets and local roads. And so on the cracking side, what's actually happening is we're actually looking at the stresses involved in our concrete pavement. So you can see here with this equation where we've got our stresses that our concrete is going to be exposed to, you can see that we can mitigate that through the thickness of our concrete. And that's what's actually going on in Pavement Designer. You don't actually need to know this equation. It's just important to understand what's going on. So our thickness is a very important thing that we're getting out of our concrete pavement design. Additionally, it goes along with those stresses. You can see that stress is compared to our concrete strength. We get a stress ratio, and we kind of control the stress ratio to determine how many load applications our pavement can hold. So that that relationship between concrete strength, thickness, and the load applications that our pavement is exposed to is really how most of these pavement design programs actually work. Now, this is a conservative approach for designing for concrete pavements because it has size effects. Most of that fatigue data is actually based on fatigue beams. Slabs inherently can actually have a higher capacity for what they can handle. Additionally, those support for those fatigue beams is a simply supported beam as opposed to our slabs, which we assume are fully supported by a subbase and subgrade. Now, on the faulting side of things, that's cracking. Now we're talking about faulting. Our faulting models were actually developed in the 1980s, so a little later on, and that's because at the AASHTO road test, everything was doweled. So they didn't really see much faulting information, or didn't really obtain much faulting information in the 2-year road test at the AASHTO road test. So later on in the 1980s, when we started building pavements without dowel bars, started to notice that faulting could be a problem, especially if we're not having those dowel bars in there. So we developed an erosion model that actually looks at faulting within Pavement Designer. So this is something that's a little more empirical, but it's something that we're looking to improve as well. But it works pretty well, especially if you do have a pavement that's not seeing a whole lot of truck traffic, or a pavement that you're actually looking to dowel effluents. And so one of the last big leaps with Pavement Designer is that we're actually looking at load spectra. And this is a big jump from AASHTO 93 because we're not estimating traffic in the form of easels or equivalent single axle loads. We're actually designing based on the number of trucks our pavement is exposed to. So you'll see how this is incorporated into Pavement Designer in just a second when we actually look at the program. But it's important to know that the load spectra is a great big jump from that easels design of the old AASHTO design methodology. Additionally, load spectra is how PavementME designs for concrete pavements as well. Okay, so a little summary on PavementDesigner.org. So we built this thing mainly for design of streets and local roads, really because those AASHTO design methodologies were moving towards a better design methodology, but they were associating a fairly hefty price tag to it. So we built this thing for cities, counties, local roads, anything that's designed with that, but also for professors and students. We recognize that a lot of places, when you teach pavement design, may not be able to teach, or we want something else besides just AASHTO 93 for designing concrete pavements. And so professors and students need to have access to tools that can do other things like designing with a mechanistic empirical approach like PavementDesigner.org does. So having all of this in one tool, we can design for different things. Having it at one site is really a great resource, and making it free to everyone is really what we were going for, and it's really a great tool for designing any type of concrete or cement-based pavement. So with that, let's check out PavementDesigner.org. Carl, are you going to help me out getting PavementDesigner.org up, or getting me a web browser so I can show it? Thanks. Okay, so we're just going to real quick go through an example on PavementDesigner.org. You can see how easy it is to design a concrete pavement. Here we go. All right, thank you, Carl. So you can see when you go to PavementDesigner.org, you can start designing right away, or you can actually log in and create an account. If you log in and create an account, it's still free, but then you can actually save your designs online, and you can access them from anywhere and come back to them. So once we start designing, you can see that our first selection point is what type of project we're doing. Are we doing a parking lot? Are we doing a street and local road? Or are we doing an intermodal industrial facility? So if we're doing just a street and local road, a conventional concrete pavement, we're just going to go in here, click concrete streets. And then we can choose the type of design we're doing. Are we doing an concrete overlay? Or are we doing a full depth concrete pavement? And these flip screens are very handy for kind of walking you through the design and what we're trying to actually do with this. Or you can actually do a new composite where we're looking at those cement modified support systems as well. So let's go ahead and do a concrete street. And you can see here we're brought to our first actual design screen. And each design is broken into our project level details, our pavement structure details, and our pavement summary. So it's a 1, 2, 3-step process, fairly simple in getting to our pavement design. So the first thing we have to do, we have to select a traffic spectrum. This is that idea of load spectra. So these are spectrums that are actually built into the tool. So you can see here I can do residential, collector, major and minor arterials. We also have ACI spectrums within the design, or you can create your own custom spectrum if you already know the traffic that you're exposed to. So I'm just going to say that I have a collector street, and I want a design life of, let's just do 30 years for this. Then I have to know my traffic, and in terms of traffic, I'm looking at trucks per day. I'm going to say I have about 150 trucks per day. And then now we need a traffic growth rate, directional distribution, and design lane distribution. And the great thing about Pavement Designer is if you're kind of confused about any of these inputs, we actually have help screens. So you can actually turn help screens on and off. I tend to have them off all the time because I use Pavement Designer quite a bit. But if you're new to Pavement Designer, you may not know these things. So if you're looking at trucks per day, you may want more information on this. So you can turn help screens on, and you can look at what the typical range of truck traffic would be for each of those different types of spectrums that we have. So residential, collector, major and minor arterial. See what a typical value would be for my average annual daily traffic, truck traffic. About 150 trucks would fit right in with my collector, collector spectrum, which I selected just a few seconds ago. All right, so for traffic growth rate, it's probably going to be somewhere between 1 and 4%, or maybe a little higher if you're in an area that's growing significantly. Directional distribution, this would be if I'm splitting my traffic 50% on the northbound, 50% on the southbound. But for this example, let's just say all of my trucks are in the northbound direction, so I have 150 trucks going northbound. So 100% are in that northbound direction. And then if I have multiple lanes going in that northbound direction, I can say that 90% of my trucks are in the design lane, or 100% of my trucks are in the design lane if I only have one lane. Let's go ahead and say 100% of my trucks are in that design lane. Next, I have a design reliability, which again, if I look at my help screen, it'll give me an idea. I have a collector type roadway, my recommended reliability somewhere between 80 and 99% for urban. So I'm just going to say 85%. Percent slabs cracked very similarly is going to be about 15% if I looked at my help screen. Just happen to know that off the top of my head. You'll see that my calculated traffic results come up here as well. And so what this is doing is it's taking that 150 trucks per day, applying that traffic growth rate, applying it over my 30-year design life, also applies these directional and design lane distributions. And it'll tell me my average trucks per day in the design lane over the design life, as well as the total trucks that it's designing for. Now it applies this over my load spectrum over here, which you can see the actual axle loads and the number of axles per 1,000 trucks that I'm expecting. And that's all based on that traffic spectrum that I selected in that very first step. So this will update based on the spectrum that I'm selecting here. So now I can go on to my pavement structure, and here I can choose if I'm doing my conventional jointed plain concrete pavement or if I'm doing RCC or CRCP. Most of the time I'm going to be doing my jointed plain concrete pavement. And then I can choose my pavement structure. You can see here we got to do a little information on our subgrade, a little information on our concrete materials, and finally our structural layers in between our concrete surface and our subgrade. So the first information I need is a little information on my subgrade. I can either input a resilient modulus to the subgrade, or I can estimate it from a CBR value and an R value. I know Florida uses an LBR sometimes, and that's something that we're looking at possibly integrating into Pavement Designer at some point. But right now it's not in there. So right now I'm going to design off CBR value. Typically around me in Illinois, CBR of 3 is something that I'd see fairly often. So you can see it calculates a resilient modulus for me based off of that CBR value. Next thing we need is our concrete strength, and we can base this off of a number of things, whether it be flexural strength, compressive strength, modulus elasticity, or split tensile strength. So if I know that I'm going to specify around a 4,000 PSI mix for compressive strength. One more, there we go. And then it'll actually calculate the flexural strength for me. Now, flexural strength is what's actually used in the calculation, so that's why it's calculating flexural strength for me. Modulus elasticity is defaulted to 4 million PSI, but I can change that as well. Whether or not I have fibers in my concrete, or whether or not I have edge support, which would be a tied curve and gutter, or a tied concrete shoulder, or even a widened lane would provide edge support to our pavement. So I'm going to say I have a tied curve and gutter, so I'm going to say yes. And then I can have 1 to 3 sub-base layers, and that's going to be layers in between my subgrade and my concrete surface. I'm just going to say I have 1 layer. It's going to be a granular base. And it's going to be about 4 inches thick. So now Pavement Designer is going to calculate a composite K value. It's going to combine the subgrade and the granular base to get my K value, and it's going to give me, what you can see there, 219 PSI per inch, or I can override that with a user-defined K value if I wanted to as well. I'm just going to leave it as the Pavement Designer calculated K value for now. So then I can move on to my design summary, and you can see here that it calculates my minimum thickness for my concrete, calculates it for both doweled and undoweled sections. When they're equivalent, we know that the erosion design is not really driving the design, it's driven by cracking. You can see here the recommended design thickness rounds it up to the next 1/4 inch. We also recommend a maximum joint spacing. If you're on yesterday, we talked a little bit about jointing our concrete pavements. Well, this maximum joint spacing is giving us an idea of what the recommended joint spacing should be to help make sure that our jointing design is matching up with our pavement design as well. So we also have some sensitivity plots here where you can see how your pavement design changes based off K value, flexural strength, design life, reliability, and percent slabs crack. So if we click on any of these, you can see that it's fairly dynamic, and you can see what happens if my concrete strength went from, I think it was about 580 flexural strength. If we went up to 600 or 650, you can see that it does change fairly significantly like my concrete pavement design. You can see how those other inputs would actually change this as well. We also have cracking and erosion reports. This is giving you an idea of what's causing the most damage in your pavement. You see my cracking life consumed is nearly up to 100%. So that means cracking is controlling my pavement design. That's what we're mitigating most. On the erosion side, not much of the erosion life is taken up because I'm in a doweled scenario. If I went to undoweled, it increased a little bit. But you can see my erosion life is not really driving the design because I don't have fairly significant truck traffic with that collector spectrum and only 150 trucks per day. So it gives a little information on load transfer, whether or not dowels should be used. In this case, if we're in that kind of a pavement, we're likely not going to use dowel bars. And then it gives a little information on joint spacing as well. So the last thing that I'll show is that you can actually generate a report right online. And so you can download, or you can provide a little more detail on your design, what the design name is, designer's name, download and view the report. If you have a pop-up blocker on, you need to make sure that you turn that pop-up blocker off. See here, pulls up, and there's my concrete pavement design report from Pavement Designer right online. So there we did a Pavement Designer design fairly quickly, and I'd love to make sure that everybody else has enough time, so I'll finish it off there. And if you have any questions, I'll take them either now or we can wait until the end and do our little round table there.